So let's start with the serverless system. So myself, Badal Dobariya, and I'm going to take you with the amazing journey of a serverless system. So as we can see, what is a serverless system? It tells us you just don't have to worry about the server. You just have to do the code, right? And so the serverless computing, also known as a function as a service, and it is a cloud computing model that allows developers to build and run applications without the need to manage the underlying server infrastructure, which means that whenever you are building an application and suppose you are doing a startup, you don't have to worry about the server, like where I'm managing the server. You just have to do the code and just put a function as a server. So whenever you want to scale up your server infrastructure, automatically scale up. So in a serverless system, developers focus on writing code for individuals, function, or service, and the cloud provider task care of provisioning, scaling, managing the server required to run the functions. Under the standard infrastructure as a service cloud computing model, users purchase the unit of a capacity, meaning you are pay a public cloud provider for always on a service run in your application. It's the user's responsibility to scale up the server capacity during the time of a high demand and to scale down when the capacity is no longer needed. The cloud infrastructure necessary to run an app is active when the app isn't being used. With the serverless architecture, big contrast, apps are launched only as needed. When an event triggers, app code is run, right? The cloud provider dynamically allocates the resource for your code. The users stop paying when the code finishing executing, right? So you don't have to pay, which is you are not choosing. Whenever you want to use this function, you can pay. So it is a pocket friendly. In addition to the cost saving and benefit, the serverless frees developers from routine and manual tasks associated with the app scaling and server provisioning. So as we can see in our screen, there are many servers we are defining. So if our uh, entire application is very big, so we are separating them and into a multiple function, which is only triggers when the particular event is occurred. So let's see the serverless architecture. As we can see in the screen, if you have a shopping website, right? So you are not putting whole your website into the server EC2 instance AWS something. What you can do is that if you know that my shopping cart goes very high demand when there is a sale, right? So you put the function on the shopping cart API. So what happens is that whenever the shopping cart gets very user demand, so it automatically scale. So whichever the cloud provider you are using as a function as a service, they will provide you the more computational power. They provide you more scaling and flexibility to use this one. And whenever the usage of the function is reduced, it automatically goes down. It releases the computational power and all that thing. So let's see how traditional architecture is differ from the serverless computing. So firstly, let's talk about the cost. We have it. So the vendor charges based on the number of functions executed, which are done, timestamp, and are allocated to run a function. But in a traditional architecture, costs are always there to maintain it. From the network perspective, in serverless computing, it requires some private APIs. But in traditional, we requires to access any APIs, we requires the regular IPs. From the integration perspective, if you are using any third-party libraries and all that stuff, you have to manually import in every function. But if you have a traditional architecture, you can just put in any function and just run it. So it will apply to the whole infrastructure that is based on the cloud. And talking about the multiple environment, it is easier to set up a multiple environment in serverless architecture But in traditional architecture, it is tough and requires additional expenses, time to set up multiple environments. Let's talk about the scaling. So the scaling up and scaling down is very easy and convenient in the serverless system. But in traditional architecture, you have to acquire a new server. You have to acquire new computational power, and there is need of a people to manage those things. So you cannot just do the scaling and scaling and descaling very quickly. So let's see how serverless is included in microservice. So if I have microservice in my application, so how I include serverless system in that. So the microservice is a way to design an application, while server is a way to run an application. We know that, right? So in other words, you can create a serverless microservice by writing the code for a microservice and then setting it up to run as a serverless function. Any microservice that needs to run only occasionally is a good candidate for a serverless microservice. Serverless and microservice are always comparable in that they require similar approaches to monitoring and management. The more microservice or serverless function you include in your environment, the more moving piece you have to keep track of, and the more robust your monitoring and log management tool need to be done. So what if my serverless function is failed, right? So whenever you are building a serverless system, that has to be keep in mind that you have to be precisely manage the architecture before the building, because if some function is failing, maybe it is depending upon some other function, and it will also break it easily. So we have to be determined that our serverless function architecture is very efficient. So let's see, where is a server in the serverless? There are servers in the serverless, but they are abstract away from app development. A cloud provider handles the routine work of provisioning, maintaining, and scaling the server infrastructure. Developers can simply package their code in the container for deployment, and they are good to go. Once deployed, serverless app respond to demand and automatically scale up and scale down as needed. Serverless offering from public cloud provider is a usually mentored on a demand through an event-driven executing model. As a result, when a serverless function is sitting ideally, it doesn't cost anything. So what is the role of the cloud provider if we can create our function as a service, right? What is the need of the cloud provider? So under the serverless model, a cloud provider runs a physical server and a dynamic allocation. They have resources on behalf of a user who can deploy code straight into the production. Serverless computing offering typically fall into the two groups. The first is a backend as a service, and the second one is the function as a service. More commonly, when developers refers to the serverless, they are talking about the function as a service model. Under the function as a service model, developers still write the custom server side logic, but it's run in a container, fully managed by a cloud service provider. So what is the difference between backend as a service and a function as a service? So the first difference we can get out from this is the flexibility. Function as a service offers more flexibility as a developers have a control over the specific function they write and deploy. On the other side, as a backend as a service, if you are using, provides predefined service with limited customization option. Let's see the second one, the development approach. Backend as a service allowed developers to build application using pre-built backend as a service, whereas in a function as a service, focus on developing and deploying specific function that can be triggered by an event. So suppose suppose I implemented one function as a service in a login page. So whenever the login page trigger, my function is triggered, and if I am not using that one, so it don't trigger, and function as a service still be just sitting quietly. So let's look at this third difference, the scalability. Both Backend as a service and function as a service can scale automatically based on demand. However, in a function as a service allow more fine-grained scaling as an individual function can be scaled independently, while in a backend as a service are typically scale the whole your application. So let's see the main thing, the price model. Backend as a service provider typically charged based on the usage metrics such as a number of API call, data storage, or active user. Pricing is usually structured around the usage of the pre-built backend as a service offered by a provider. But in a function as a service, you will only charge the invocation, the execution time, and the allocation resource to you for each of your functions. The pricing is more closely tied to the actual execution of the function rather than the usage of the specific backend service. Let's see which other function service provider we have it till now. So we have Amazon Web Service with AWS Lambda function. We have Azure functions. We have Google Cloud function. We have IBM Cloud function, and typically a cheap option we have it is an OpenShift serverless system. Let's see the life cycle of a serverless system. So whenever the serverless system is started by developing a code, right? And after developing a code, you integrate with the function that you are defining in your application. After it will deploy, and whenever the event triggers, it just get on, and auto scaling is happen when there is many requests come in your system. Also, you are paying only for the bills that you are using on a system. So it is only whatever you are using, you are paying only for that one. And it also provides monitoring, logging, and all that thing to keep tracking of your applications. And there is a continuous improvement. So if you want to scale your function as a service, you can do it. Also, it provides you the maintenance and the decomposition properties. Let's see the common use cases of the serverless system. So the most common usage of the serverless system in the current world is for the chatbot as a scaling, HTTP REST API call, continuous integration pipelines, stream processing at scale, microservice architecture, scheduling batch job, especially when event parallel computation or IO is required, changing the data capture or database update, process multimedia task, handle input from the IoT sensor. Let's see the pros and cons. So the first thing, you don't have to manage the server, right? Because the function as service is also doing the same thing. So your time is automatically saved. The second one is a cost. So it will also benefit your pocket because you are only paying for the service that you are using. The third one is the scalability. You can scale it and scale down as far as your need. And there is a quicker time into market. So whenever there is a huge demand accelerate in your system, it automatically scale up. And if there is no demand, it also automatically scale down. And it is an event driven, it follows the event driven architecture, which means whenever the event triggers, your function as a service runs. So let's see the cons also. Everything has a pros and cons. It also has, the first one is the vendor lock-in. So if you, while in a certain possibility to pick and choose a service from a different vendor, the easiest way to go will be on usage of a single cloud provider, such as AWS. Since such each vendors will have their own way of doing things, this can be challenging if you ever want to migrate to a different provider, and you will completely will retain on the vendors to provide automatically service at all times. Let's see the security cons. So cloud providers will often run code from several customers on the same server at any given time. They do this by using the technique known as a multi-latency. Let's see the performance impact on the serverless system. So the serverless computing is not constantly running when a function is called for first time. It requires a cold start, right? The last disadvantage is debugging and testing. So debugging is a complex to reduce visibility of a backend process that are managed by the cloud provider. Additionally, a serverless environment can be difficult to replicate in order to perform integration test. That's it. Thank you guys to listen to me.